Hello everyone, welcome to the machine learning session. And we are learning how you are going to classify your data and to create linear regression model using scikit-learn. So basically in the previous class, we have created a prediction model and that was like yet not completed. So let's quickly revise what we have done till now. So we have taken a raw data. Basically, we have created this data without any null values and which has a dependency. So that's why we created a two-column data where we have 100 rows in it. So we have like the first input value is going to be study hours and the output is going to be exam scores, where we have kept different random hours, that is study hours, and therefore in the increasing order as compared or with respect to the number of hours, we have kept the scores accordingly. So basically, when you are, before we go into machine learning and create any machine learning model with it, what we are going to do, as I have already shared with you, the moment you are going to create any data, if you feel the data is simpler, what you can do in your Excel or wherever you have created the data, you are going to select the entire data and you are going to run the analysis by clicking on analyze or analyze the data. The moment you are going to click on to this particular segment, it is going to create a graph for you where you can see the dependency. That is a very, very important step. Why it is important? Because with the help of this particular field, you can actually see the data dependency. As you can see over here, exam score is dependent on the study of hours, and you can see a linear line along. So I'm going to add, as you can see, that it has till 15 hours. So let me quickly add one more line over here, and I'm going to give 20 hours. And over here, the exam score which I'm going to keep, that is going to be maybe 100. All right. So I'm going to keep 100 or 98.7. So that is going to be the score. Now, if I'm going to select the entire segment, I'm going to delete this first. And now I'm going to analyze and I'm going to insert this. Now over here, if you can see, right? 20 and it says approximately 100. So this actually tells us the dependency, right? Because the exam scores are completely, or you can say directly proportional to study of hours. If you are going to study in on this particular straight line, which is catering the entire data precisely near it, if you wanted to calculate in between 15 and 20, there will be 13, 14, or you can say 16, 17, 18, 19. All are going to be in between 80 and 20, right? So this is the inference which you are going to get. So similarly, your machine learning is also going to work according to this particular segment. So basically what I'm going to do, if I'm going to create a straight line, so let me quickly open my whiteboard over here and let me quickly share that inference in front of you so that you'll understand it. So similar way, the way we have created our previous model, which was of linear regression, where we have calculated years of experience and salary. So we are going to do the same. I'm going to open a blank canvas over here. Now I'm going to take a line. Okay, I'm going to do this. Yeah, and black. I'm going to take a straight line. Right. This is my, not really, set this. This is my hours. So I'm going to write hours like this. And this is going to be score, SCR. So I'm going to write short forms of it. Now I'm going to create a line over here. This is how the line going to go. When scores are increasing, Similarly, our R's are increasing. And therefore, the values are like this. Over here, and this, right? So these are all scattered in this way, according, right? Now, at every R, so if I'm going to take, let me take this, the rainbow pen. This angle is your M. Let's consider it as M1. Okay, this is my M1. And basically, at every step, this angle is going to be changing. This is going to be M2. And similarly, if I'm going to take this angle, this is going to be mx. So accordingly, the formula which we are going to follow, that is going to be y is only one output which we want, right? Y is equals to mx plus c, correct? This is what we are taking. Now c is constant over here, but our m and x value is changing. So how you are going to take as m1 plus or m1x1, right? So I'm going to take this m1x1 plus m2x2. X2. Similarly, this is basically for our number one. This is for our number two. This is for our, and basically it is going to come along. So this is how the calculation is happening. And how this calculation is happening, this is by calling upon the object, which is model is equals to linear regression. And we are calling upon the model which we have taken from scikit-learn. Now, once that calculation is calculated, it is ready to train the model by using model.fit. Model.fit is going to train the model accordingly. So we have run that. Now I'm going to take you to the code which we have created on Google Colab. So till now, what we have done, till now we have imported. So I'm going to mark it as hash import libraries. So here we have imported the libraries. Here we have load the data set. Here we have visualized the data and the pattern. We have split the data. We have trained and predict the data. And here you can see here most of the calculations are happening, which I have just shared with you. Now, basically, we have done the comparison. After comparison, the next part is we are going to calculate the error percentage which you are going to get in it, which you are going to share with your client. So now let's quickly do that. Basically, we are going to import the libraries, which is mean squared error and R2 squared. Basically, it is MEA and MRMSE. So that is what we will be doing. Let's quickly do that. So basically, the commands which you are going to write, let's write it. I'm going to scroll down. Here you are going to evaluate. So this is step number 9. You are going to write MSC, which is mean square error. So let's call it mean square error is equals to mean. Basically, I'm not going to write this. I'm going to write in simple form MMSE. That is mean squared error. What we are going to predict with that? Y test with Y predict. That what exactly is the difference in that? Create it, right? Once we are done with that, we are going to understand root MSE, because this is mean squared error. Now we have to mention the root value. we have to convert, we have to create a square root of that, because earlier we are just squaring it. And why we are squaring it? Because there will be some negative values if you are going to look onto, let me quickly show you. Over here it is 2 and over here it is -1. So to eliminate the negative value, we have to square the value. All right. Over here also it's 74. This is 64. So 10. And this is accurate. 35. So there will be -2 in it. Right. So -2, if you are going to square, then it is going to become 4. That is like when we are going to sum and calculate the mean of it, that is going to come in positive, so that it is going to provide us a accurate value rather eliminating or rather cancelling out. Okay, so that is what we will be doing. So let's quickly do that. RMSE is equals to MATH math.sqrt square, and what we are going to do, MSE. So we are going to convert that square root in this. It's okay. We are going to redefine it. Now we are going to run R2. I'm going to explain what R2 is going to do for you. R2 score Y test and Y predict. All right, once you are going to run that, now you are going to print all these values. Print, what you are going to do, /n model evaluation. And what model evaluation is going to be? Print mean squared error, and then you are going to call upon round, MSE, and 2. Round means it is means the value which you are going to calculate, it will be in floats. Now you are going to keep only the float value till 2 decimal numbers. So that is what round does for you. All right. Now, similarly, we are going to do print root mean squared error. That is going to be, after this, I'm going to put the comma, and then you are going to put round RMSE, and that too also with 2, round of 2. Print R square score R2. Yeah, that is what you will be doing. That also we have kept as 2. Now, once you will be running it, let's see what that value is going to be. So this is what we have kept over here. Now, let me quickly explain what these matrices are going to be, how you are going to explain this particular segment. All right. So the first one which I have kept, that is for your uh, basically mean squared error. So basically, when you talk about mean squared error, MSE, mean squared error, so that is a range of the squared errors which is the least value is going to be the better value. Suppose it is going to tell you how much error is there. So if you are going to get 1%, 2%, 3%, so lower is the value, better is the result, better accuracy. So it says कि आपकी कितनी mistake है इसमें, कितनी गलतियां आपने की हैं, कितना डेटा है जो मैच नहीं हो रहा इन सिंपल वर्ड्स. जब हम बात करते हैं आपकी RMSE, RMSE is like MSE. MSE means आपका mean squared error, but easier to understand in some unit as the output. इसको हम square करेंगे, जैसे अगर हमारा result आ रहा है -2, आप उसको square करोगे, it will be converted into 4. अब 4 को आप दोबारा से root करोगे, then it comes as 2. It means 2% जो है आपका error है इसके अंदर. And lowest the value that is going to come as output. Now to last आपका जो square है, it measures how well the model fits. 1 means perfect. अब 0.8 है, 0.9 है, 0.7 है. How near it is towards 1, that is going to show you the accuracy of it. So once you have understood that, now let's see how it is going to run and gives the output. So I am going to run the entire part and let's see actual value. And now you can see model evaluation. Mean square error is 16.34. When you are going to square root, mean square value is going to come as 4%. And that is 96, means it is 0.4 left. One is absolutely perfect, means 100% matching. And R square is coming at 96. It means your accuracy is 96%. I hope now you are understanding. If you are going to run this prediction, the prediction accuracy, it shows as 96%. And 96% is said to be an accurate value. Accuracy is 96%. More than 50% if you are getting, it shows that your accuracy is good. But if you want a perfection, it should be more than 90%. So well done, everyone. You have attained 96% of accuracy, which is a very good model. Keep it up, all of you. I hope you are enjoying. And this time I have used a different platform for all of you, that is Google Colab. I hope you all have understood how to get started with Google Colab. In Google Colab, you need not to get started like you are not going to pip install anything. You are just going to import the libraries. You are going to add a sample data and get started. Once again, would like to tell you how you are going to upload the data and how you are going to utilize the sample data. So let me quickly take you to this particular folder. If you are going to click onto it, it has first sample data. When you are going to click onto it, there are multiple sample data which are available for you. First is README, then it's like California housing test. It's in CSV, California housing train, that is CSV. So both test and train are there. This is Minis test data and train data. So you can take segregated data or you can take the entire data, and from the data you can run the predictions, right? So this is how you are going to run predictions in it accordingly. So basically, what we have learned today, we have reached at the end of our segment. This segment actually contains a lot of things. So in simple words, would like to share, we have done the classification. Classification means how you are going to use scikit-learn, how you are going to classify in train and test. You are going to split the data and run the prediction. When we talk about classification, over here we have used linear regression for the classification because the data was simple. In this data, we have done the simplification or regression only with two aspects. We had only one input and we had one output. For better inferences, let me take you over here. As you can see, study hours is considered as our input and exam score is considered as our output. By considering these two, we have run linear regression. We have seen how y is equals to mx plus c is going to work and run the calculations accordingly. With those calculations, we have calculated and we have come across with this particular prediction. where our data shows 96% of accuracy. Now, one by one, I'm going to reiterate all the steps which we have used. Let me take you to the code itself so that you'll understand it in a better way. So here is the model. Let me open this model in front of you. Here is the model. Step number one, we have imported the libraries. We have imported pandas as PT. Why we have done that? To create the data frame and to define X and Y values in the data frame so that it can run the analysis, right? Pandas is being considered as the Excel of Python. Now, later we have the second library which we have imported, that is Seaborn. Seaborn is part of Matplotlib PyPlot to plot the chart and graphs to visualize the data and to find patterns in that. Once we have done that, thereafter we have imported scikit-learn model to select and to run import test and train split, with which we are going to segregate the data into two parts. One is going to be your testing part and another is going to be your split part. So over here in the course, if you can see, this is the line where we have test and split the data. In this, we have the data which we have kept in X, that is input, where we have kept in Y, that is output. We have run that by keeping test size. Test size means in the testing, we are keeping only 20% of data. When you are going to run, you can actually see that all these are 20 rows, total 20 rows. So this is your testing data. Once you have run the testing, you are going to see what is X test and Y test. Now, to train and test the model, we have used model fit and model linear regression. With that, we have trained the model on the data set which we have created. The 80% of the data is being utilized to train the model. Once we have trained the model, we have actually see the comparison, how our testing and how the predicting model looks like. So if the testing says 12 is the score for 0 hours, then the predicted value is going to come as 10. For 10 hours, 33 and 35. So likewise, it is happening. So basically, this is actually the serial number, not the number of hours. So for 17, 17.32, so accuracy is similar to that, only 1 or 2 points less or high. With that, we have calculated by putting MSE and RMSE for the evaluation. And later at the end, by using R squared, we have calculated the predicted model. In fact, you can use model.predict command also to predict the model accuracy, which is going to come exactly or like approximately near to 96. Over here, as you can see, R squared is accurately 0.96, which shows 96% accuracy. So this was about this particular session. So here we have reached at the end of our third module, which was classification using scikit-learn. Now I hope you have understood what is the role of pandas, what is the role of Seaborn, what is the role of scikit-learn, as well as how you are going to run the prediction. What exactly you are going, which method you are going to use to find exactly you are going to find the prediction, you are going to find the classification method and how you are going to train, whether that is model fit. Now there is one segment which students were asking why we have used this particular command that is called Ravel. Now Ravel is actually very important in terms of how you are going to utilize this particular segment. Basically, when we talk about Ravel, Ravel actually converts the segment into two parts. For pandas, it is necessary that we are going to convert the entire data frame into only one dimension. Only then that dimension is going to be considered. If you are going to see, it was inside list, which converts into two-dimensional. So by using Ravel, we have converted into one-dimensional list. That was the significance of this particular aspect. With that, let's just do the recap. in this particular segment, what we have done, the entire segment was all about how you are going to run linear regression. Linear regression is being done on you can say standardized data, where we have taken a structured data. We created the data ourselves. We have kept two columns only, and we have run all 5 steps to create the data. These predictions are accurate predictions which you have created by using all those 4 steps. Please do remember all those 4 steps. Only the classification is going to be changing, or the mathematics behind the data or behind the model is going to change. The rest, each and everything is going to be same. So stay tuned with us. And in the next class, we are going to work with multivariate regression, in which you are going to take multiple inputs and output is going to be one. How you are going to run the predictions in that by using scikit-learn library only. Let's work on that, and we will be seeing you in the next class, everyone. Thank you so much and stay tuned.